Let's take a closer look at the simulation unit system using the shoebox energy model. We have the input geometries here, internalized in these data placeholder components. The geometries are then scaled by a factor and then fed to these components to create zones, windows, shading, and boundary conditions. The scaling factors are controlled by the unit conversion factor. The unit conversion battery is only necessary when the unit for the input geometries in your Grasshopper is different from your Rhino document. The from input should be set to the unit of your Grasshopper geometry. In this case, the Grasshopper geometries were modeled in meters. The battery converts the unit to the active Rhino document unit. In my case, it is also in meters. So if you hover your mouse over the output variable, the conversion factor is 1 because it is converting from meters to meters. So in this case, I can bypass the scale battery and directly connect the input geometries to create a thermal zone. The results will be exactly the same because the scaling factor is 1. Unlike some other simulation tools, Climate Studio uses the unit of your Rhino document as the default unit. So for the to input variable, you should always leave it to active Rhino document unit. To verify it, let's try a few tests. Show the input geometry for the zone. You can see that the geometry shown in green is exactly overlapping on top of the energy model, which is shown in white. Search deconstruct box. Connect the output geometry from the scale battery to B. You can see that the x dimensions of the box is from 0 to 6. So it is 6 meters from here to here. The y dimensions are from negative 0.8 to 9.2. So it is 10 meters from here to here. So the area of this thermal zone is 6 by 10 equals to 60 square meters. We can verify this from one of the visualization panels. If you connect a panel to the floor area output, you can confirm that it is 60. If you hover your mouse over the floor area output, you can see that the unit is in square meters. Now let's change the unit for the Rhino document to feet. You can see that the thermal zone geometry in white is much bigger than the Grasshopper box, which is in red inside the white box. If you hover your mouse over the output of the unit converter, the factor is now 3.28, which is the factor from meter to feet. Go to the deconstruct box battery. If you hover your mouse over the X input, the range is from 0 to 19.7, which is the number in feet for 6 meters. If you run the simulation and check the floor area output, it is still 60 square meters. My recommendation is that you keep the unit system consistent for the document setting, the input geometries in Rhino if you have any, and the geometries in Grasshopper. Always model them in the same unit system, and you can skip the unit conversion battery, and you are less likely to make your mistakes. If you prefer to model in feet, then set the document unit to feet, model in feet in Rhino and Grasshopper. So in this case, I need to change these values to corresponding numbers in feet. If you prefer to model in meters, make all three consistent in meters.